Okay, so it's been a while, and the work is largely complete on this SB-100 restoration. This will be part two. Apologize for the delay in putting this video out. Okay, so as you look at this radio, the first thing that you see is the front panel is really rough, and I have not been able to source anything to make it look any better. Part of me says it's part of the history of the radio, and so we'll just kind of leave it alone and operate it as it stands. So part of me also being kind of a vintage amplifier kind of guy, I like the fact that it's an honest radio, and all the front panel switches work. The oscillator mode switch, you'll see if you look closely, has been blanked out for the crystal position. That switch was bad in the radio, and so I've had to make another switch work, which I was able to do. But it never comes off the LMO position anyway, so that really doesn't matter much. But on the front panel, everything's fine and everything works. So let me change over to an internal view of the radio here, and we'll do some more talking. So here's a nice internal view of the radio. You can see that the circuit boards are really clean, and I used the N5 OLA method, if you will, to cleaning out these boards. Got it in the sink, lots of soapy water. Instead of using dish soap, I actually have an electronics cleaner solution that I used. And I got it very, very clean. It looks great, top and bottom. So in addition to everything done here on the radio, let's recap some of the other stuff that I believe I put in the other video. Power supply has been rebuilt. All the capacitors were changed. The diodes were left alone because they were fine. And I don't like circuit breakers, so I removed that and put in a fuse holder with an appropriately sized slow blow fuse. Excuse me. So that took care of the power supply. The radio was an awful lot of work, and a lot more work than I thought it would be. First thing, and I brought this up in the previous video, the band switching network is, in fact, all of the switches are very, very susceptible to tarnish. In fact, the contacts were all literally black. And so in order to get that taken care of and make the radio operate stably, all of those switches had to be very, very thoroughly cleaned between using deoxit spray and also the brush-on solution and a Q-tip going in there and actually scrubbing all of those surfaces. If you do not do that, if those band switches or any of the switches on the radio are not clean, it will not ever operate properly. So repairs made otherwise besides that. If you pay close attention in the first video, you'll see that the 100 kilohertz crystal was missing. I've replaced that, and the 100 kilohertz calibrator now works properly. Also, I replaced the output transformer because I turned the radio on. I'll blame myself. I turned the radio on too soon after washing it, and that transformer was not completely dry, and that caused some issues there. And if you look closely on the boards as well, I'll bring up, if you see any blue or beige resistors, those were changed due to them being out of specification. All of the electrolytic capacitors were replaced. That's an easy job. And I will tell you, the most difficult thing to wrangle into submission was the AVC circuitry and making sure that that works. And I will tell you that these service bulletins that are available on the internet are extraordinarily valuable if you're going to work on one of these rigs. Basically, every diode in the radio has been replaced. There's some diode switching that goes on with the AVC circuit. Those diodes all leaked. They test fine. If you use a DVM and test the diodes, they'll test just great. In circuit, they leak. And as a result, the AVC circuit becomes very unstable. Also, the service bulletin highly recommends against the use of RCA tubes in terms of the 6AU6s in the circuit. I can tell you that I found that to be true. I replaced the RCA tubes with General Electric tubes, either straight up 6AU6s, but mostly I tried to go for the 6AU6WA tubes, the military tubes, or the 6136 tubes. And that finally got the AVC circuit working great. S-meter works great. It all hangs in there, and everything is fine with regard to that. I did replace the finals with the recommended 6146A tubes. They recommend against the use of 6146B tubes due to the differences in the tube. And my transmit is fine. I have 100 watts out on all bands, with the exception of the 29.5 to 30 megahertz band, because I have a dead crystal. I'll have to get that fixed eventually, but I'm not a 10 meter guy, so I'm not in a big hurry for that. I went through the alignment process for both the receiver and the transmitter per the Heathkit manual. Very straightforward process. Everything's fine. The receiver is very hot, works great, no problems. Now, with regard to the neutralization of the finals, I tried to use the process per the manual, and I found that to be extremely difficult and very unrewarding. I could not get the thing neutralized properly. Fortunately, I do have a number of oscilloscopes laying around here, so I did use an oscilloscope, and the process where you remove the high voltage, disconnect the screens from the final tubes, and go through and minimize the output per the process in the manual. I did not use a VTVM with an RF probe because I just like oscilloscopes better. My father was an Army electronics technician, and he taught me the value of an oscilloscope, and I use them for just about everything. So as a result, I did do that. It will work fine with an RF probe. There's plenty of videos out there on YouTube that show you how to do that, and that's fine. The same instrumentation process was used with the carrier nulling. I did replace both the carrier null and the meter zero pots with 10-turn potentiometers, and that has worked great. I was able to null out the carrier, but the pot alone was not enough for the process in the manual. There is a variable capacitor in there. I did have to use that. Interestingly, when I moved to backtrack a little bit, I'm sorry, to the neutralization process, I paid attention to where that neutralization capacitor was before I started. And when I finished the process with the oscilloscope, after having it moved all over the place with the other process, it went right back to where it was, which was I thought that to be fairly interesting. So there's been a lot of work put into this radio, a lot more money than I really wanted to, although it really wasn't that bad, but still more than I had expected to spend. But nonetheless, it is a really, really good radio. Works great. I've made contacts on CW with it, and it does great. Receiver's good. Not a lot of noise, and it functions like I remember these radios when they were new when I was a kid and fell in love with them. So that being said, highly recommend a project like this. It's a lot of fun. It's a lot of frustration, but in a good way, especially getting that AVC circuit to work on this rig. But nonetheless, it's come out really well, and I hope to see you all on the air with it. I'm going to hang on to it for a while, and hopefully I'll be able to do something about the front panel, although I'm not that worried about it. The chassis was also, the cabinet was also spray painted a god awful color, so I'm working on that as well, because that was taking it just a little bit too far. So anyway, appreciate you tuning in, and we'll see you on the air. And like I said, once they get cleaned up, get them going, it's a great radio. I really can't argue with it. So with that being said, 73, and thanks for your time.